Hello guys, welcome back. In this video, we are going to learn factory pattern. And this factory pattern is categorized under creational pattern. And as we all know, creational pattern is used to creating object and just so that the developer or the user can get a ready-made object, right? So before going to the technical detail of this factory pattern, let us see an example. So suppose you want to go somewhere, right? You want to go on a trip, whether it can be Kashmir or it can be Bangalore or it can be anywhere, right? So you don't want to deal with the hotel, you don't want to deal with the cab or anything. You don't want to deal with any type of booking, okay, because you don't have any knowledge about say like which hotel you want to book, which cab you want to book. Okay, so wherever you want to go, whether the train goes there or not, whether the cab goes there or not, you have no idea. Okay, so you just go to a travel agency and you just say, okay, see, I want to go this place. Okay, now just give me the ready-made package, okay, so that I can go to that particular place easily, right? So that trip agency, what it will do is it will book a hotel for you, okay, it will book a cab for you, okay, and it will just give all this thing into a package, and you can take that package and voila, you got the trip. Okay, you went on the trip. That's it, as simple as that. So here you are not worrying about wherever you want to go. You just tell the trip manager, okay, I want to go this place, and that particular trip manager will give you a ready-made package, and you can take that package, go to your destination, enjoy the trip. As simple as that. Okay, similarly the factory pattern work. Here the trip agency work as a factory pattern. And how's that? We will see. So suppose we have a functionality called get package for a trip. So this trip agency have a function called get package of a trip. And whenever the customer ask for any particular type of trip, the trip agency just pass the string like, okay, uh, get package trip for Bangalore, get package trip for Kolkata. Okay, and that function will return the built-in instance of that particular structure which handle the context of going to that particular place. Okay, and that trip agency just hand the particular instance of that structure to the customer, and the customer can use all the mechanism or all the method which is available as a facility from this instant, right? From this instance, correct? Now let us see the technical detail for the factory pattern. So the factory pattern method is probably the second best known and used design pattern in the industry. Okay, and as I remember, like this was the first pattern I ever used in my development career. So this was like easy to understand and easy to code. So I hope you will also get this very soon. Okay, and its purpose is to abstract the user from the knowledge of the struct he need to achieve the specific purpose. As I told, user is not bothered about, okay, what structure he want to deal. He will just use the interface. He will just use the function. He will just pass his requirement to the function. He will get the instance of that particular structure, and he will use this interface, and all the functionality will be defined in that particular interface, and he can easily use that interface as uh, getting all the mechanism what that instance can do, and he will easily use it, right? So factory can provide an interface that fit the user need. As I told, that interface will hold all the mechanism what the instance of structure can do, and the user will easily use that. It also eases the process of downgrading or upgrading the implementation of the underlying type if needed. And what it means is, if we have this factory pattern in our code or in our development phase, we can easily downgrade any type of functionality. Suppose there is a new place, okay, where the trip agency want to add. Okay, so suppose there is Andaman Nicobar where uh, previously there was no any offering for this particular place, and now he want to add this functionality or add this feature so that he can provide this feature to the customer. So he can easily add this feature into this factory pattern software. In this factory pattern, like if we have implemented his software in this by using this pattern, he can easily add it. Or if you want to modify the existing offer for a particular place, he can modify it. If he want to just delete or if you want to just remove for a particular place where he was providing the instance earlier, he can easily remove it, right? So what is the objective of this particular factory pattern? So the first one is delegating the creation of new instance of structure to a different part of the program, right? Working at the interface level, as I told, and instead of with the concrete implementation. So the user is not bothered with the concrete implementation of that particular instance, right? Grouping families of object to obtain a family object creator, and what this grouping family means. So what the trip agency, what the trip agency word hit you in the mind? Basically, it will be of like managing the trip, right? So it basically is tripping. It categorize all kind of trip into that tripping family. Okay. So now what we are going to implement. So we are going to implement a payment method factory, okay, which is going to provide us with different ways of paying at the shop. So suppose there is a shopkeeper, okay, he want a software where he can accept payment from the user in any mode. It can be cash, it can be debit card, it can be credit card, right? He just want a software where he and that particular software must have a functionality called payment method. And if you use that payment method and the pass the payment method as the argument of the function, he can easily get the payment and his work is done. So in the beginning we will have two method of paying. One is cash, one is credit card, and at the end we will try to add debit card also. Okay. So we will also have an interface with the method, and that interface method will have payment method named inside it as a signature inside it, right? So before writing our code, let us see what are the acceptance criteria for our software. So first of all, to have a common method for every payment method called pay. So this payment method should be common to every payment method, whether it is a cash payment method, whether it is a credit card payment method. Some common type of method should be there so that the shopkeeper will easily use this method, and it will be independent of the implementation of this particular of this what you can say, of that particular instance of payment, okay, or that particular type of payment, right? To be able to delegate the creation of payment method to the factory, obviously, like whatever the creation of payment method is, it should all be dependent upon factory, not the user. Okay. The user will just pass the requirement and he will get the instance of that particular requirement from the interface, and he can easily use whatever the method signature which is defined inside the interface as the functionality of that instance which he will get, right? Also, to be able to add more payment method to the library just by having the instance of it. So before writing the actual code, let us see the template which we are going to write, and later we will write the unit test case for the same. So initially we are having this payment method interface, and this payment method interface will have a functionality called pay. So here we are having a signature called pay, and whatever the type of payment we will get, whether it is a debit card payment, whether it is a cash payment, or whether it is a credit card payment, all those payment method will implement this pay signature which is defined inside payment method interface. Also, we will having a function which will return us the instance of any payment method, right? So for now it is returning nil because we have not implemented any payment method yet. Okay. And here we are having some payment method type. So the user or the customer can reach to the shopkeeper with the cash payment, with the debit card payment. Okay. So for now, if the user reach to the shopkeeper with the cash payment, we are doing nothing here. We are just returning empty string. So this is just a template. So based on this template, let us see the unit test case for the same. So initially what I just told, so this test case is a type of use case of a factory pattern. So what I just told, we can have the variable of type I interface. So payment method was the interface, and we are just having the variable type of that particular interface. Okay, and we are also having the error type. Okay, and we are just using this payment variable to get assigned to the instance whatever type we want. So initially we want cash method, so in this function if we pass cash, we will get the instance of cash payment structure, right? And we can easily use the pay method which was there inside this payment method interface, and we can easily just pay the bill, right? Similarly, later we will see if we pass the same function we are using, but we are passing a debit card payment method, and there we will get the instance of debit card structure, and we can easily use the pay method which was defined inside the interface. And which interface it was? It was payment method interface. We can use this same pay method, and voila, the shopkeeper just accepted the payment, and he got the cash, right? So let us see the actual implementation of this. So initially what we are having is we are just defining our constant. So suppose cash will represent 1, so that we can pass cash into the function parameter, and it will be 1. It will be just integer. So comparison will not be of type string, it will be of type integer, right? And here we are having a payment method interface. Okay, and inside this we are having a signature called pay. So yeah, this is the function which will give us the instance of different payment method based upon the condition which will be passed as a parameter inside this function. So suppose whether it will be 1 or it will be 2, right? So 1, cash represent this integer 1, debit card represent this integer 2. Okay, and this function will accept either 1 or 2, whether it will be cash or whether it will be debit card. Okay, and based upon the condition, based upon the requirement, this switch case will give the required instance of the class. Okay, so suppose if this function got if this function get request for cash payment method, the function will easily return the instance of cash structure. If this function get called for debit card payment method, this function can easily return the instance of this debit card structure, right? And if this get payment function does not have any implementation of any particular payment type, it will easily return an error saying that this particular payment method is not recognized or it is not implemented yet. So let us have a cash payment structure and a debit card payment structure. And initially these structure are just empty. We are not doing anything, because just we are trying here. We are just trying to understand the factory pattern design. So this particular structure will try to implement the cash payment method, and it will be pay, which it will try to implement this method signature, so that whenever we create the instance of this cash payment structure, it will be accepted by the variable of type payment method. Similarly, we are having the same for debit card. So now let us see if we want to test this code. So here we are having the variable of type payment method, and here we are just calling this function, and this function will return two argument. One will be error if there is any, and another is the instance of that particular payment method. So if we got any error, we will get this fatal. So our execution will stop at this point. It will not try to execute further. Similarly, if we are trying to, so whatever the payment we are trying to pay, so suppose we want the cash payment method, we get the instance of cash payment method. Now we want to use the functionality which is defined inside this interface, and which is pay. So he will simply write the whatever integer or float he want to pay, and that will be paid, right? Similarly, if we want to check for debit card, we can just request this method to get me the instance of debit card structure. Okay, and after calling this function, we will get two instances. One will be payment, and that will be the instance of debit card structure, and we will get error if there is any, right? So this is checking for if there is any error or not. And if there is no error, so we got a instance of that particular debit card structure. Okay, and the structure of that debit card has already implemented the pay function which is defined under this payment method interface, right? And using that instant and using that functionality, user can easily pay the bill and shopkeeper can easily accept the bill in to whatever the requirement it was. So let us run this test case and see whether it work or not. So it's all working. Okay. And last, so here what we are trying to do is we are trying to get the payment method of some random integer, and as we know this implementation is not there in our code. So what it will does, probably it will return an error. In this case some error will be there and there will be no instance. Okay, so as you all guys know, if we don't want any variable name in GoLang, we can just have underscore, so it will be like no name of variable. Okay, so that we will not be bothered to use that variable in our code. So we're just checking, like we are expecting some error and we will get an error because this particular payment method is not implemented yet. Or suppose what you can say is there is some int, some payment method which will be uh, Paytm, okay, which is equal to 3, and sorry, now you are trying to have the payment method via Paytm and it won't work because we have not implemented this Paytm yet. So now let us save this code and try to run this test case. And as you all see, we got an error for this particular test cases. So as you guys can see, we do not get any error because we were expecting this particular error will be some value, it will contain some value. So to check whether we got an error or not, we will just try to log it. Now save the code and run the code again. So now if you want to check whether we got the error or not, you can just change the condition. So if error is not equal to nil, it will print this particular error. And if you save it, if you run it, you will get the error because this error is not nil now. Okay, as you guys can see, not a valid payment method. That's it, guys. So now if you want to add further any extra payment method, you can easily add it. Just have that particular structure type, okay, and then you can define the payment method for that particular structure, which for example here we have credit card payment method, and just include this thing here right now. So it can be like case uh, credit card payment. If that is the scenario, simply return new credit card payment and error will be nil. As simple as that. So whenever this function got the requirement, so I want the payment method as a credit card, you, the user will easily get the instance of this credit card payment method and he can easily pay the required bill. So as you guys see, whether it was a cash payment method, whether it was a debit card payment method, or whether it was a credit card payment method, all the functionalities have the same functionalities, and which is pay. But there's a difference between the mechanism for paying to different cash payment method for different payment method, right? So as a rule of thumb, factory method creational design pattern allow creating object without having to specify the exact type of object that will be created. So user does not know what type of object will be created. User will only pass the requirement to the function and he will get the instance of that particular object, and he can use all the method which is defined inside the interface as the functionality of that particular instance of structure, right? So that's for the day, guys.